video will show you the procedure for operating the Cuttermaster tool grinder. The machine is easy to learn and you'll be sharpening the tools you want within minutes. First, we'll go over a few basic safety points. It's important that you follow these guidelines at all times, before 50 RPM. And never use a grinding wheel that is cracked or has any kind of defect. Prior to turning the motor on, always ensure that the wheel hub nut is secure and flush with the wheel. When using a new grinding wheel for the first time, start the motor from the rear of the machine and let it run for a minute in case of cracks or damage to the grinding wheel which may have occurred in shipping. Don't wear ties, loose clothing, or any item that could possibly become caught up or entangled in the grinding wheel. PSI. Don't use the air bearing in temperatures below 65 degrees, as colder temperatures can cause metal expansion that will cause the air bearing to lose its clearance for airflow. Slide the air bearing fixture on the X-axis table by aligning the two guide pins into the T-slot on the X-axis table. Position the right-hand side of the air bearing's black swivel base approximately 1.5 inches, 40 millimeters, from the right end of the table. Set the angle of the swivel base to 2 degrees to the left side of 0 to facilitate a 2-degree angle fishtail on the NT. And securely tighten the retaining nut that is on top of the black swivel base. If you want a flat bottom end on the end mill, set the air bearing swivel base angle to 0 or whatever angle you wish. Put the machine to the brass fitting on the back side of the air bearing fixture. The arrow that indicates airflow direction on the air filter should be pointing towards the air bearing after installation. Use Teflon tape to reduce air loss. Connect an air supply with a minimum of 90 psi to the air filter using a quick disconnect setup. The air filter we supply you is a water trap only. Never use any kind of oil or lubricant in either the air filter or the air bearing fixture itself. And never move the air bearing without at least 90 pounds of air pressure applied. Check the pivot screws on the air bearing to ensure that they have not loosened in transit. They should be tight enough so that the air bearing has no side-to-side movement, yet loose enough so that it can rock freely. Slide the Stylus bracket assembly in the slot on the front face of the air bearing and tighten it. Clean the air bearing fixture out thoroughly. Remove the spindle carefully, leaving the air on. This allows any dust or debris that may have settled in the air spindle housing during the packing shipping process to be blown out of the air ports. Keep the air on. Clean the inside of the air bearing housing with a cleaning solution that leaves no residue, such as acetone or MEK. Do not use WD-40, glass wax, or any other type cleaner. After cleaning the inside manifold, keep the air on for a minute to allow the cleaning solution to fully evaporate, and then wipe the inside again with a dry, clean cloth. Clean the air spindle with the same solution and carefully replace the spindle back into the housing. It is important to periodically clean the air spindle in this manner to ensure long life. Thoroughly wipe out the inside of the air bearing spindle where the collet goes. Debris that come between the collet and the inner spindle surfaces will affect your concentricity. An oxide grinding wheel that If you're using the pink aluminum oxide grinding wheel that was supplied with the machine, you'll need to dress the wheel. We suggest that you cover the air bearing fixture while dressing the wheel. Manually dress the wheel at a 10 to 20 degree angle using a dressing stick. The angle itself is not important. What you're doing is creating a sharp edge. For sharpening high-speed steel tools, we recommend that you use a CBN wheel, as they do not require dressing and there's no wheel breakdown, which means that they're much more accurate. They also provide the best finish. If you'll be sharpening carbide tools, you'll have to use a diamond wheel. Never use a CBN or aluminum oxide wheel on carbide. If you'll be sharpening tools and need the closest tolerances possible, hard-inch 5ST 4-split collets provide the best concentricity possible in a 5C collet. With a 4-split design and a deeper throat, hard-inch 5ST collets can hold concentricity within 5/10 and better. Hard-inch 3-split collets are a close second best, providing concentricity between 5/10 and 1/1000. Other 5C collets can be used. Please consult the manufacturer. The height of the stylus needs to be set first. The height is to be kept at the same height as the center line of the air-bearing spindle. This is critical. If this setting is incorrect, then your end mills won't cut properly, as the clearance angles will be off. To check the center height, place a setting pin in the air bearing by using a 5C collet, and then raise the stylus to the pin. Using a clean 5C collet, mount the collet and the end mill in the air spindle. Tighten the drawbar, ensuring that the end mill will not come loose. If your collet is dirty or out of tolerance, or if the air bearing's inner surfaces are not clean, this will affect the concentricity of your end mill. Maneuver the stylus inside the flute of the end mill. You want the stylus as close to the outside edge of the end mill OD as possible, without being too far out, so that the grinding wheel will come in contact with the stylus instead of the end mill. Tighten the set screw. Check the OD of the end mill. And obtain the primary clearance angle listed under first grind for that diameter from the clearance angle chart on the front of the machine. Crank the clearance adjustment handle and raise the motor spindle until the proper angle is set on the vernier scale, which is on the side of the motor. If you are machining harder materials, you may want to adjust this angle to 1 or 2 degrees less than the angle given on the clearance angle chart. Materials such as aluminum would require increasing the clearance angle 1 or 2 degrees. We have an optional pneumatic finger attachment available that eliminates cranking up and down of the motor to set the clearance angle. The pneumatic finger is shown later in this video. Using the machine's X and Y axis handles, Position the stylus directly in front of the right edge of the grinding wheel. The middle of the stylus should be in front of the high point of the grinding wheel's edge. Position the stylus roughly a ½ inch, 13 millimeters, in front of the wheel. Slide the indexing ring all the way to the right of the air spindle and lock the set screw. To avoid denting the spindle, don't bear down too hard. Place the end mill on the stylus as far right towards the shank end of the end mill as it will go. When grinding end mills with the right hand spiral, you will always pull the spindle to the right. Never push the end mill to the left, as this will cause the end mill to jump on the stylus. It is very important to keep the end mill on the stylus at all times while you are grinding. If the end mill jumps, this will cause gouging on the OD. When pulling the end mill during the grinding process, you want a slow, smooth movement to obtain a clean finish. After positioning the end mill on the stylus, turn the motor on with your left hand. Advance the grinding wheel until the wheel touches the OD of your end mill, and then feed another 2 to 3 thousandths. Pull the air spindle to the right, being sure to keep the tool on the stylus, using a slow, steady movement. It may take a little practice to get the feel of this. After you pull the end mill off the stylus, rock the air bearing back towards you and position the next flute on the stylus in the starting position. Slowly lower the air bearing back down onto the wheel and pull the end mill back as before. Repeat this with all remaining flutes. For a little better finish and to compensate for wheel wear, if you're using a bonded wheel, you can take an additional 1/1000 cleanup pass on all the flutes. We suggest that you take an old end mill that is no longer in use and practice pulling the OD a few minutes before resharpening with good cutters. Once you've got the feel of this down, the rest is easy. And set the angle on the motor spindle veneer accordingly. Proceed to grind the secondary in the same manner as used to sharpen the primary. To save time, the best way to do this is to grind one secondary clearance angle on one flute until the width of the primary angle is the proper size. Then proceed to sharpen the remaining flutes. Be careful that you don't take too much off and wipe out the primary or burn the end mill. The secondary grind is only necessary if the primary is too wide. It is not a necessity to do the secondary grind if the primary is already ground to the width desired. Setting the motor spindle angle to 0 on the veneer. When the motor is set to 0, the air spindle center line is 1/2 inch below the center line of the grinding wheel. This provides a 7-degree clearance angle off of the radius of the wheel OD. Remember that the angle that is preset on the air bearing swivel base is the angle that the end teeth will have. Loosen the indexing ring and bring it flush to the back end of the air bearing housing. Push the pin, which is on the top center of the right side of the air bearing, into a slot in the indexing ring that is marked with a number which matches the number of flutes on the end mill. While holding the index ring firmly against the housing, push the spindle so that the end mill is past the stylus at least 1/2 inch. And then align 2 parallel flutes until they are square to the table. Tighten the set screw in the index ring. When you grind, you will be maintaining a steady pressure of the index ring against the air bearing housing so that the end mill is not pushed back when the contact with the grinding wheel. Some users may prefer to push the air bearing spindle all the way to the right. Set the flute square and then lock the index ring in place so that they don't have to hold the air spindle in place. However, this will entail either cranking the table forward a distance to compensate or repositioning the air bearing forward by loosening the swivel base nut and sliding the air bearing forward. Maneuver the grinding wheel with the Y-axis handle so that the edge of the wheel is about 1/2 inch in front of the center of the first end tooth. Using the X handle, feed the end mill forward until the end mill touches the wheel. Back the wheel away from you off of the flute using the Y-axis handle. With the X-axis handle, feed the table forward to the left 2 to 3 thousandths, and then with the Y-axis handle, feed the tooth across the wheel to the center of the end mill and back. You'll know when you hit the center of the cutting end mill as the grinding sound fades due to the fact that there is less material being sharpened at the center. Index to the next flute and repeat the process until all flutes are done. If you're wishing to sharpen the secondary clearance angle of the end teeth, drop the motor spindle angle down to a -8 degrees and repeat the same procedure as before. You can sharpen the ends of all 2 flute end mills, 3 flute, and 4 flute non-center cutting using this method off the OD of the wheel. For 4-flute center cutting and 6-flute non-center cutting end mills, the end mills must be sharpened off of the face of the grinding wheel instead of off of the OD. To do this, remove the Stylus base assembly from the air bearing. Slide the motor back about halfway on the Y-axis table. Loosen the swivel base nut and rotate it 88 degrees clockwise, allowing 2 degrees for relief. Slide the air bearing fixture to the left so that the end mill now faces the wheel. Set the motor spindle angle to a -4 degrees. Repeat the same procedure as before, setting the flute square to the table, setting the indexing ring, and feeding the end mill across the wheel. To be able to grind some 4-flute and 6-flute center cutting end mills, an 1.5-inch riser block underneath the air bearing fixture is recommended. This process elevates the tool to the upper radius of the wheel, enabling you to reach the center of the tool without running into the other flutes. With the 1.5-inch air bearing riser block as shown, the end mill is now above the center line, being ground on the upper radius of the grinding wheel. This gives the clearance to reach the center of 4-flute, 6-flute center cutting tools. This will require a positive angle of 6 degrees primary on the motor head, a secondary relief of 20 degrees. Your angles may vary. Check with the end mill manufacturer. We'll now show you how to use the pneumatic finger attachment. First, install the pneumatic finger's 3-way air fitting into the air bearing. Remove the old Stylus bracket assembly and install the pneumatic finger bracket assembly. Insert the carbide stylus into the stylus holder and leave the set screw loose. Place the 1/4-inch setup pin into a 1/4-inch collet. Set the air valve to the up position and dial finger away from the wheel until it stops. Set the height of the stylus to the center line of the air spindle by bringing the carbide stylus up to the 1/4 inch setting pin. If the carbide stylus happens to be too long, you'll need to grind the bottom of the stylus off to fit. You will need to reposition the pneumatic finger bracket so that the stylus is directly under the point of the setting pin. Tighten the set screw for the stylus holder and tighten the stylus bracket screw. When using a pneumatic finger, the motor angle is left at 0. If needing more or less clearance, the motor angle can be adjusted accordingly. For more clearance, raise the motor in the positive direction and lower the motor for less clearance. With the motor left at 0 and using the pneumatic finger, the tools will be ground to the same clearance as shown on the chart. With the switch in the up position, dial the knob until the stylus rests underneath the flute you are sharpening. Position stylus at the right edge of the wheel as done before. And proceed to sharpen your primary angles. Secondary angle is achieved by flipping the switch down.